Gibbs free energy equations again. We have just for a given state or for change. Change in Gibbs free energy is what tells us how much energy is available to do some type of work with. And delta G is a predictive quantity, so we can use its sign to decide if something is favorable, likely to occur, and which direction would be spontaneous. So the first term is our enthalpy term, delta H. It is equal to constant pressure heat flow, right? In biological thermodynamics, we can think of delta H as just the heat absorbed or released from the breaking or forming of chemical bonds. And I think I asked you guys to draw figures like this at one time or something kind of similar, where essentially you're looking at the difference in delta H is going to be the enthalpy of the products minus the enthalpy of the reactants. So if products minus reactants would be a negative value, it's exothermic, okay? Delta H has a negative sign, exothermic, a decrease in enthalpy. In our enthalpy term, there's no real reaction coordinate is over here. Alternatively, if the enthalpy of the products is higher than the reactants, you would have a positive delta H. This is an endothermic reaction or an increase in enthalpy. Okay. For entropy, delta S, okay, if you let these two things mix together, the sign of entropy or delta S would be positive as we're increasing the overall randomness disorder. And the last term is tau. When delta G is less than 0, it's spontaneous. When delta G is greater than 0, it is non-spontaneous. For example, a ball rolling down a hill would be a spontaneous process, whereas we do not expect it to be able to roll itself back up without some input of energy. And what is the only other option besides less than or greater than 0? Equal to 0. Okay. All right, so delta G is less than 0 or is spontaneous. The term for this is exergonic, okay? Think of it as energy exits, EX, negative, just like exothermic fluid in. So here's what that free energy curve would look like versus sort of, again, just some sort of progress of the reaction or progress of whatever's happening in the system. So you have reactants, there's some initial energy that you may have to put in order for things to continue spontaneously. Like I said, this is like a local min. These reactants are stable, they're hanging out, they're happy, but they'd much rather react and become these products because this is a global minimum for free energy, but there may be some initial input. And then the change in free energy, delta G, is products minus reactants. This is going to be a negative value. The enthalpy term, okay, is for an exothermic reaction. Okay, if you have a negative enthalpy term right here, and you have a positive entropy term. So if this is negative, a negative minus a positive will always be negative. Okay, so the way that I want you to think of this is if delta H is negative and delta S is positive, delta G is always negative. And I want you to put that on, there's a box on the worksheet at the bottom, right? There's like a table. It says fill it out together as we do it in class. And it says, so it has if delta S is greater than 0, and it has if delta S is less than 0. And then over here it has delta H less than 0, so this is exothermic, right? And it has delta H greater than 0. It has endothermic. So what part of the box are we in for the always spontaneous situation? Top left, okay? If it's delta H is negative, delta S is positive, this is always spontaneous. Okay. So for a delta G greater than 0 or a non-spontaneous reaction, we would call this an endergonic reaction. Think of it as energy enters, sort of similar to endothermic. So what I would like you to do is draw an energy diagram, the first part, draw an energy diagram for the endergonic reaction, properly label the axes, the reactants and products, and the delta G on your drawing, and then discuss with your team the signs, positive or negative, for enthalpy and entropy change in order for the reaction to always be non-spontaneous and place it in the box below. So, please do that with your team now. Draw the picture, fill in the box for always non-spontaneous.